Welcome to our tutorial about ionic compounds. What are we going to talk about? Well, we're going to first talk about a definition of what an ionic compound is. We'll talk about what ions are, electron transfer, and then importantly, how to make or draw a diagram showing electron exchange. So firstly, what is an ionic bond? Well, it's an attraction that happens between oppositely charged ions. Those are positive ions and negative ions, and from that we will get an ionic compound. We require an electron transfer between atoms of different elements to make it happen, and ionic compounds have strong bonds, very strong bonds. So they hold compounds together. So if you think about some common examples, there are so many, but think about salt that you have on your table. It's not falling apart, is it? Concrete, that's held together by ionic bonds, and many other things too. They tend to have high melting points and high boiling points, and they conduct electricity when molten or when dissolved in water, because then the ions are free to move around carrying the charge, the electric charge. So what are ions? They are an atom, or sometimes a group of atoms, that have got a charge. That charge could be positive or negative. Metals form positive ions or cations. Non-metals will form negative ions or anions. And groups of atoms can form positive or negative ions. There's many more examples of negative ions when we have a group of atoms. And ions have either gained electrons to become negative or lost electrons to become positive, and they're the result of electron transfer. So let's show what this looks like. Here we've got an example, a sodium atom, and you can see the dots on there show that we have 11 electrons in 3 electron shells. There's 1 electron in the outermost shell, and that is lost when sodium forms an ion. The electron comes from the outer shell, and notice it's the only electron in the outer shell. Some atoms will obviously have more electrons than that, so may lose more than 1 or not lose electrons at all. So we describe the electron as lost, but actually it's not lost, it's transferred to another atom. It can't just go into thin air or be lost. So it's going to be transferred to an atom of some other substance, and it's whatever sodium is reacting with. So here we've got this sodium atom now shown below the arrow, and you can see there are now 2 electron shells. We don't draw the empty third electron shell from which we've lost the electron. And both those electron shells are full. That's the reason that sodium wanted to lose 1 electron, was to have full outer shells. And notice that we have square brackets and a positive sign around the diagram, and that's showing the overall charge on that ion. Okay, let's do an example of making or forming a negative ion. So our example here is an oxygen atom, and that's going to gain electrons to become a negative ion or anion. So oxygen has 6 electrons in its outer shell. It wants to have a full outer shell, so it has space for 2 more electrons, and so we can draw arrows coming in for electrons gained. Oxygen is accepting those 2 electrons and forming an ion. And again, those electrons haven't just appeared from nowhere, they're being transferred from whatever that it is that oxygen is reacting with. And at the bottom of the page, under the arrow, you'll now see the oxygen ion, the oxide ion in fact, and that we've put 2 black dots in there to indicate the new electrons. Actually, they're exactly the same as the electrons oxygen has. It's just to try and show that these have been introduced into the ion. And now we have a full outer shell of electrons, and the brackets and the 2- symbols show the overall charge on our ion. So if we're making a diagram of electron exchange, let's look at the the top part of this diagram, we have sodium and chlorine reacting, and it's a metal and a non-metal, of course. We're using an arrow to show the electron transfer from the outer shell of the metal atom, and the end of the arrow is at the outer shell of the non-metal atom. So if we have more than one electron being transferred, not in this case, but if our metal has more than one electron to lose, we would draw more than one arrow. So we're going to draw the resulting ions, and that's at the bottom of the page here. We have the sodium and the chlorine atoms. Okay, remember to show and include the square brackets and the charges on the ions. So you can see the sodium now with the brackets round and the positive sign, and the chloride ion with the brackets round and the negative sign. So in summary, ions are atoms that have either lost or gained electrons, or sometimes they're groups of atoms. And they have a charge which could be positive or negative. Atoms lose or gain electrons by electron transfer to get this charge. An ionic bond is caused by a strong attraction between oppositely charged ions. You don't get this between two positive ions or two negative ions. It has to be positive and negative. It's a strong bond. Ionic compounds have high melting points and high boiling points. The molten ionic compounds can conduct electric current because the ions, once molten, the ions can carry electric current. Similarly, solutions of ionic compound can also conduct electric current because the ions are free to move. So next we're going to talk about covalent bonding, so join me in that video.